Welcome to December's BTS lecture. And as many of you will be aware, this is the Tideway update again, as we've been doing this for a number of years now. So tonight, you are all in for a bit of a festive treat with not just one project, but the annual update across the entirety of the Tideway Project. So first, a little bit of housekeeping. I've been informed there are no fire alarms this evening that are due, so if it does go off, please follow the emergency exits for your nearest exit point. Next one, if I could please ask that everyone puts their phones on silent or turns them off, that would also be great. So, tonight we are joined by Maurice Gallagher, who is standing in for Andy Alder, who is sadly unable to join us this evening, but I know that he will be watching on from home, and I think hoping and waiting for his countdown of when he can be released. And I know there's many others who unfortunately were not able to join us here tonight for similar reasons. So, tonight's Christmas selection box brings us an overall Tideway update and a number of short talks from Tideway West, Central and East. And our speakers tonight are, we have Maurice Gallagher, a chartered civil engineer and fellow of the IOM3. He has experience in heavy civils and tunnels with both UK and overseas experience. He commenced his career underground in 1987 in the Docklands, working for Miller Construction on an LDDC project, and undertook numerous electricity and water projects in London, Folkestone, and on the Isle of Wight. Maurice then joined the Murphy team constructing the Angel Station before moving eventually onto the Jubilee line with the Aoki Corporation. After a stint in Singapore, he returned for the CTRL with Hochtief Murphy. In 2005, he joined Balfour Beatty Management, Parsons Brinckerhoff, as the tunnel delivery manager for the King's Cross project, and subsequently carried out several consultancy roles, including Doha Metro, Bond Street Station, London Bridge Station, Crossrail, Northern Line Extension, and the Tel Aviv Metro. Maurice works for Jacobs and is, for a few more weeks, the deputy delivery manager for the eastern section of the Tideway Project, having spent 7 years on the project. We then have our next speaker will be Jennifer Eyre. Jennifer is a site engineer at Tideway West and currently part of the team delivering the hydraulic structures at the Dormey Street site. She started on the project as a summer placement student based at Putney in 2017 and returned following graduation from Oxford University with a Master's in Engineering Science. In 2018, Jennifer joined the Frogmore team at Dormey Street for the start of shaft sinking using the sprayed concrete lining SCL method. She naturally progressed to working as a shift engineer on Tbm Charlotte, which was used to deliver the primary lining of the Frogmore connection tunnel. She has since joined the surface team to continue the delivery of the hydraulic structures and shaft internals, which has included the successful secondary lining of both Frogmore shafts at Dormey Street and King George's Park by Slipform. Our next speaker is Ignacio Tognaccini-Sainz. Apologies. He's an industrial engineer with over 5 years of experience in the tunneling industry. His first job experience was in Seattle, USA, on the rescue operations of famous Big Bertha. After successfully completing the project, he continued his career path in London and joined Ferrovial at the Thames Tideway Central Tunnels, where Ignacio played a key role in the fabrication, commissioning, on-site assembly, and launch of the 2 TBMs. Soon after, he became the production manager of the secondary lining, leading on the planning and design of the shutters, the moving of the gantries, and the logistics part of the whole operation. Ignacio has led the tunnelling team in Tideway Central to successfully complete almost 10 kilometres of secondary lining over the last year, consolidating the main tunnels at Tideway Central as a strong reference for future tunnelling projects. The next speaker then will be Ricardo Manias. Ricardo is a mechanical engineer currently working for Ferrovial UK in Tideway Central. He has professionally grown within the company step by step for the last 5 years, starting as a shift mechanical engineer in the Northern Line Extension, helping with the assembly, launching and dismantling of both TBMs. After the completion of the NLE tunnels, and for almost 4 years at Tideway, he was promoted to deputy plant manager. He is in charge of the mechanical assemblies in Tideway Central, including the assembly and commissioning of the key innovative elements sent into the tunnels and the daily maintenance of all the plant required for the daily production. He is one of the key people delivering the secondary lining works at Kirtling Street. And then our final speaker is Matthew Campbell. Matthew has spent his career in tunnelling, working on wastewater projects. Firstly on the Belfast Sewers project in 2007 as part of a year in industry as part of his degree. After graduation, Matthew then moved to London and started with Morgan Sindall on the Lee Tunnel project in 2011. He started during shaft construction and then worked on the Tbm drive and the secondary until 2016. He then moved to Tideway West in 2016 again with Morgan Sindall and was involved in the early planning stages and site setup prior to a year's design placement with AECOM working on the Tideway Central design. After this, he then returned to Tideway West in 2018 as shift manager for the launch of the main tunnel Tbm and the tunnel drive to completion, as well as the connection tunnel works. Earlier this year, he moved to Tideway East with Costain as shift manager on the Greenwich connection tunnel and has managed to bag being on all three parts of the project. So I think without further ado, we'll invite the first speaker.
Thank you. Good evening, Maurice Gallagher, and I am here because Andy is suffering with COVID currently, so he's in isolation. It's interesting that 3-4 weeks ago I had COVID and I was in isolation. So me inheriting Andy's duties today feels a little bit about symptoms of long COVID for me. But Andy as well, mild symptoms. And we put it down to, we're both vaccinated, so get yourselves vaccinated, you know it makes sense. We've got a packed agenda today, so you're not going to hear too much from me. I'm going to give you a quick overall progress update, what we've done in the last year, and then I'm going to hand over to Jennifer, who's going to talk about the Frogmore connection tunnel, Ignacio and Ricardo to talk about secondary lining in the central section. And one point to note here, because he won't mention himself, last night Ignacio was nominated as the Young Tunneler of the Year at the awards dinner, so we're lucky to have him tonight. And then we'll follow up with the east section. Matthew is going to talk about one of the few tunnels that's still ongoing on Tideway, the Greenwich connection tunnel. I'll come back just to answer Bob's questions, when are we going to finish Tideway? So I'll come back and do that at the end. So very quickly, and I'm not going to spend much time because I think most people probably understand why we're doing Tideway. We've got combined sewer systems when it rains heavily. Stormwater combines with foul water, and we get discharges into the River Thames. It happens on average once a week, and I think annually 70 million cubic metres of sewage flows into the Thames. That's the problem we're trying to rectify. And the solution is we're intercepting those flows. On this sketch here, you can see this is at our Victoria worksite. You can see the Bazalgette sewer there just to the left of the tube tunnels, where we effectively break into the side of that and via interception structures transfer the flows when they get too high in through our interception structures into the shaft, which are constructed down through, in this example, through the foreshore of the River Thames, via a vortex down to effectively a stilling pond at the bottom of the shaft before entering the main tunnel, in this example, by a connection tunnel. We do have some shafts that are on line to the main tunnel, eliminating the need for a connection tunnel. Overall, we've got 23 sites, 25 kilometres of tunnel that goes from Acton in the west out to Abbey Mills in the east, where we connect to the Lee Tunnel. The main drive sites you can see there are the orange dotted numbers. 7 is the drive site for the Western contract at Carnworth Road. Number 11 in the centre there is the Kirtling Street site at Battersea, from which the central contractor has driven both tunnels back to Carnworth Road and east to number 17, Chambers Wharf, which is the drive site ongoing at the moment for the Eastern Main Tunnel and will be the reception shaft for the Greenwich connection tunnel. I am going to just very quickly, effectively do a bit of a safety moment. We deliver our tunnel segments to site by river. We're currently doing that at Chambers Wharf, and they come by barge to the site and are offloaded effectively by a grab. The grab is effectively remotely operated, so no one needs to go near the segment stack as they're being lifted out of the barge to eliminate that risk. Recently, we had an issue with the grab. It got stuck on the segment stack and couldn't become dislodged. Tim, barge operator, was asked to go in and push a button on the grab to release it. He did so. The load released, but it shifted and trapped Tim's arm. Tim's now off for at least a year, maybe life-altering injuries to his arm. And it just goes to show how easy these things can happen. Someone just trying to do the best they can to get on with the job and doing something that perhaps they're not fully aware of the risks involved with doing that sort of operation. But on Tideway, we have a process that we try to roll out all the time. It's difficult because these sorts of issues happen all the time where people just go a bit above and beyond to keep the job going. But on Tideway, we use a process called step back, where if we spot any change, if anything doesn't look right, we're trying to encourage everyone just to stop, a couple of minutes, think about it, think about the issues, think about does someone else need to be consulted, look at what the problem is, and do we have to put in a new safe system of work before proceeding. So just a shout out to everyone who's running sites. Now it's only a couple of weeks to Christmas. Let's take a step back and make sure everyone goes home safely for Christmas. Well, I am now just going to run on to and talk very, very quickly about some overall progress in the last year. Main tunnels, initially west. You see the Frogmore connection tunnel there is circled. We're going to talk about that later, so I'm not going to deal with that. But the west main tunnel, this time last year, the TBM, it just finished really. The TBMs were being dismantled. And since then, we've dismantled the TBMs, cleaned out the tunnel, installed secondary lining formwork, and in west now they've concreted over 1 kilometre of the secondary lining in that section of the tunnel. Staying in west, there was also an SEL main tunnel element where they had to connect to the central main tunnel. That tunnelling was complete. It's only 140 metres long, but quite onerous works. The SEL works were completed, and now that section of tunnel is being lined, and it's about a quarter the way through. In central, 12 kilometres of tunnel, all done. The final tunnel connection happened November last year, and that's the TBM breakthrough into the CVB shaft at Chambers Wharf. And since that point, or up to date, they have got 9 or maybe even 10 kilometres of secondary lining now complete. And in the east, the only section on Tideway where we are still tunnelling. The Greenwich connection tunnel there circled. We're going to speak about that later, so I'm not going to talk about that now. But the main tunnel is 5.5 kilometres long. Around this time last year, in November, the TBM was delivered. It came all the way from Heron Connect's factory in one piece all the way to side. And during November, it was all being assembled in the shaft, etc. And this was happening at the same time as the central TBM was breaking into the base of that shaft as well. So there was a lot of works being undertaken through that period. And to date, now in November 21, 2.8 kilometres of tunnel done. So just over half of that tunnel complete. And work's really progressing well in those tunnels. Off the tunnels, just very quickly, on a few of our sites, our CSO sites, our shafts, you'll see this type of thing in many shafts. This happens to be a Blackfriars. A year ago, the shaft wasn't excavated. Wasn't fully excavated anyway. What you can see here is the Vortex Accelerator tubes being constructed. All the structures at the base. You can see the online main tunnel at the base of the shaft there. And the Vortex Accelerator are being brought up the shaft concurrent with all the concrete, both for the surround to the vortexes themselves, but also as the secondary lining for the shaft. And just another shot. Here, this one is one of the smaller sites, but at Deptford. But just to show the scale of some of the works that we're doing, off to the right of this photograph will be the sewer that we're intercepting. So the flows will be coming in Eventually, from left to right, the sort of triangular steel section that you can see being assembled there is what we call a Vortex Accelerator. So the flows will eventually come through from the sewer into that accelerator, which accelerates the flow into the vortex tube, which spins the sewage and takes it the 60 metres down to effectively a stilling pond at the base of the shaft. But like huge, the scale of it is huge. And that's why I'm just showing a few of these photos, because it's quite big plumbing, really. And across all the rest of the sites, and there's just a couple of photographs here, are some of the interception structures that are now being constructed. You can see here King Edward Memorial Park and at Falconbrook, but it's happening across 20 or 23 of the sites currently. These works are happening now. On one or two of the sites, it's virtually complete, all of these works. And it's quite interesting. I was down recently with the insurers down at Blackfriars and walking through some of the structures there. It's almost like walking through new underground stations because of the size and scale of the civils boxes that we're creating there. So that is a very, very quick fly-through. I need to hand over for their detailed case studies now. So I'm going to hand it over to Jennifer to give us a talk on the Frogmore.
Good evening. As previously mentioned, my name's Jennifer. I'm a site engineer at Dormey Street on the west section of the Tideway Tunnel. This evening, I will give an overview of the shaft and preparation works, the primary lining and the secondary lining of the Frogmore connection tunnel. The Frogmore tunnel was completed in two drives, one from the Dormey Street site to King George's Park and the other from Dormey Street to Conworth Road. The total length of the tunnel was about 1.1 kilometres with a depth between 16 and 25 metres. Under the river, there was 13 metres of ground above the tunnel, and it was entirely in London clay. Once commissioned, the Frogmore tunnel will annually divert approximately 18,000 metres cubed of sewage from Dormey Street, that's about 7 Olympic-sized swimming pools, and from King George's Park, it'll intercept 86,000 metres cubed, which is about 34 Olympic-sized swimming pools. One of the main site constraints at Dormey Street has been the strength of the river walls. The river walls 577 and 224 that you can see in the slide had an initial allowable surcharge of 14 and 0 kilopascals. And so you can see they're in the zone of influence of the shaft, so construction couldn't begin on the shaft until we'd shored them up. To do that, we installed 127 piles that would be able to support a slab that would support a 95-ton piling rig until it transported the loads beneath the toe of the river walls. After that, we installed contiguous piles for the river wall strengthening and also were able to install the secant piles to start the shaft excavation. The river walls had to be able to withstand both loads from the construction of the shaft and also settlement from the shaft itself and the launch chambers that we constructed for the Tbm. So the Dormey Street shaft, after the ring of secant piles, we excavated, and it was about 4 metres of made ground, 2 metres of river terrace deposits, and then 24 more metres of London clay. The sprayed concrete lining was our primary lining for the shaft, and it was sprayed in 3 passes between a thickness of 375 and 700 mil. As you can see from the slide, we did that in 1.2 metre advances, staggering them with joints at 45 degrees. We made sure to prep them with jet washing and shovel to make sure it exposed fibres so we could get good construction joints. We used a compound called Zypex in our mix, and that reacts with water to form non-soluble crystalline solutions in the pores and capillary tracts of the concrete. This eliminated our need for a separate waterproof membrane. We used accelerator between about 5.5% and 6.5%, and were fed by the 220-ton silos you can see in the slide. Once we had excavated, we made 2 20-metre launch chambers for the Tbm. These were of 4-metre diameter, They were actually 3 metres, had a vertical difference of 3 metres in height, the Carnmouth Drive being lower than the King George's Park. The King George's Park shaft was done in a pretty similar manner, except there were 9 underpinned rings to start it off. Underpinning was chosen instead of caisson due to the proximity of the adjacent cofferdam. We overall had about a 27 metre excavation at Dormey Street, and King George's Park, I think, was more like 22. So once the shaft had been complete and we'd done the launch chambers, it was time to move to tunnelling. Throughout the shaft, we were working days only on both sites until we went to the launch chambers, at which time we started employing a shift pattern of days and nights, 5 days and 4 nights. Our shifts were 11 hours long, with a break between 5 and 7:30 a.m. in the morning. That was at Dormey Street. King George's Park stayed days only throughout. And the primary lining was excavated, Frogmore was excavated using a Lover earth pressure balance tunnel boring machine. This TBM was first built in 1994 for the 4.6 kilometre long Fylde Coastal Waters Improvement Scheme. Since, the TBM had successfully completed 4 further projects, lastly the also 4.6 kilometre long London Water Ring Main Stoke Newington to New Riverhead in 2007, before starting work on Tideway. However, before being used on the project, it was refurbished and upgraded by Magnaplant to meet BS 6164 2001 and BSCN 16191 from 2014 as a minimum. Modifications that had to be made, including walkway alteration to enable minimum space requirements to be met. We reduced the manual handling requirements through the introduction of a lifting device to change the ventilation cassette and also drums for the cables. We had new rollers for a davit arm to lift tailskin and TBM grease cans. The PLC units were upgraded, and the screw was also modified with hydraulic rams to extract from the head. As you can see, the nominal cut diameter is about just over 3,300 mil. For her journey under Wandsworth, the TBM was named Charlotte, and that was after a local suffragist called Charlotte Despard. When fully assembled with 9 gantries, which is approximately 77 metres long. Charlotte's first drive was from Dormey Street to King George's Park, a journey of approximately 500 metres. With her nominal cut diameter and the external diameter of the rings, that was about 3.21 metres, there was a 75 mil annulus that was filled with approximately 0.8 metres cubed of grout, each 1 metre advance. Throughout the excavation, the EPB target pressure was 1 bar to obtain a volume loss of less than 1%. A particular challenge of this drive, as you can probably see from the drawing, was the alignment. This was chosen to avoid sensitive assets in the area and, as much as possible, to stay under the roads. You may have been wondering why I mentioned that the 2 drives are about 3 metres apart in depth, and that's because 3.2 metres below the King George's Park drive, we had a National Grid cable tunnel that we had to avoid. And then for the Carnmouth drive, we needed to be far enough below the river bed. The resulting tunnel contained 145 metre radius curves with approximately 15 rings of straight transition between each curve, and the TBM itself was launched immediately into such a curve. The rings were designed to have 12 different possible arrangements, and they are made of 6 trapezoidal segments. Each ring contained 3 different types of segments, and the maximum lead that could be achieved was just under 33 mil, and that was more than enough to ensure the 145 metre radius curves were possible. They required a 22.5 mil lead. The machine itself had been modelled to be able to get around curves of 120 metres, so it did them okay, but to help it along, we did put some steel packers in between the tail can and the stationary shell. The King George's Park drive was entirely through London Clay B formation, and apart from encountering some bands of clay stones, the excavation was fairly straightforward. The ground conditions contained anti-clay polymers, and that helped the workability to allow for extraction through the screw. After successfully completing her journey to King George's Park, Tbm Charlotte was brought back to Dormey Street to begin her drive towards Carnwath Road. As you can see, this tunnel was much straighter and mostly underwater. However, as we had begun, COVID-19 hit and the country was plunged into lockdown right as we were under some very sensitive river walls. As Boris was announcing that we had to stay at home, we actually continued tunnelling for a week to be able to do a safe stop for the TBM far enough away from the river walls. After that, we spent about 2.5 weeks at home reviewing our work practices and updating our risk assessments, before gaining approval from our client to be able to come back to site. However, when we did so, we did stick to days only and did sort of moderate the number of rings we did a day, conscious that the supply chain was quite affected by what was happening around the world. Perhaps one of the more interesting parts of the drive was around ring 370, when we were transitioning to fully tunnelling in the A3II formation. We expected that, if anything, the pressure in the head to slightly increase, but we saw that the thrust was dropping a bit, and the driver commented that he'd noticed a bit of a change in the ground. We had been warned of a potential pingo located approximately 50 metres south of the planned alignment at about ring 400, and so suspect we may have caught the edge of such a drift-filled hollow. Tbm Charlotte broke through into a reception chamber in the Carnwath Road shaft and was removed via a temporary platform. The photo showing gives a bit of a sense of scale of the difference in our connection tunnel and then the main tunnel, and there are some stats on the slide as well to compare the two. The gradients of both Frogmore connection tunnel drives was 2 mil per metre, and a key design feature of the Tideway tunnel is that the sewage will flow solely under the influence of gravity, so this invert gradient was crucial. The secondary lining of the tunnel was undertaken using shutters developed by specialist tunnel shutter supplier Kern Tunnel Technic. They developed 4 shutters that cast in a hit and miss sequence, allowing for faster production. The required nominal thickness for our secondary lining was 150 mil to leave a final diameter of 2.55 metres, and the minimum allowable was 100 mil. The 4 shutters varied in length, so for the King George's Park drive with the tighter curves, we had them be 4 metres long and extended that to 6 metres for the Carnwath drive. The King George's Park drive took a lot longer to complete than Carnwath because of COVID, and in total we had 1,420 metres cubed of concrete cast, which, as you'll hear in the next, compared to the next presentation from the main tunnel secondary lining, doesn't seem that much at all. The secondary lining of both the Dormey Street and King George's Park shafts was conducted using a slip form technique for the majority of the height, followed by several jump form advances. This was due to the changing geometry of the shaft lining around the Vortex drop tube and generator. Both slip forms were completed with 24-hour working without any unplanned stoppages. Again, there are some more statistics about both on the slide. The concrete we used was fibrous, containing 10 mil aggregate, and poured with a rate of rise of approximately 200 mil per hour. The hydraulic structures in both shafts have since been completed. Both contain stainless steel vortex generators and drop tubes, mentioned earlier, designed to cause the sewage to helically flow down into the bottom of the shaft. There's hydraulic benching at pit bottom that guides the sewage through a weir wall and into the tunnels. Across most Tideway sites, including King George's Park, both the vortex generator and drop tube are sort of set in the middle of the shaft. However, you can see at Dormey Street that it sits into the side. This is because the original proposed tunnel alignment had tighter curves, and so this was changed to be to the 145 metre radius, which meant that the tunnel had to be moved off centre of the shaft. The shaft itself couldn't be moved because of the tight constraints surrounding its location. Fittingly, both Dormey Street and King George's Park finished pouring their cover slab upstands on the same day. Working on the Frogmore connection tunnel has enabled me to learn about different tunnelling techniques and work with a range of people with vast tunnelling experience. And I'm very grateful to all those who have taken the time to answer any questions I've had as a very green graduate. Thank you for listening. I believe that questions will be taken at the end of all 3 presentations. On to Central.
Hello everyone. My name is Ignacio Tognaccini. I'm a tunnel agent at Frogmore Construction UK, and here beside me I have Ricardo Manias. Ricardo is the Deputy Plan Manager, and we both work at Killing Street in the central section of works, as Maurice pointed out. And today we're going to talk about secondary lining, which is the main activity that we have been doing over the last year, and I hope you all enjoy it. So, as you probably know, we're in the central section. There is 5 kilometers to the west up to Canworth Road and 7.6 kilometers to the east up to Chambers Wharf. The tunnels were constructed and finished on 2020, which led to having a primary lining that would guarantee the water tightness and the structural loading of the tunnel. However, in order to get as well the requirement of the durability, we had to construct as well a secondary lining inside the tunnel. With this secondary lining, we will make sure that the tunnel in the future is going to prepare for 120 years and is going to be able to resist the abrasion of both the wastewater and the water coming from the ground. And this is the reason for which we construct a secondary lining in the project. Secondary lining for us has been pretty much an innovative operation. We had many lessons learned from past projects like the Lee Tunnel, so we decided to think as a team to try to think out of the box and try to come up with new ideas, new solutions in order to overcome the difficulties of the past. And one of them, a key one, was the cast in situ option with the secondary lining shutters that you can see at the picture in the screen. These shutters were built by Tecosam, a Spanish manufacturer, and we had the opportunity to collaborate with them and co-design with them what you pretty much see here, a prototype that had never been tried in the industry and that has been able to give us the fantastic achievements in both production and quality in the whole operation at the tunnel. The shutters, as you can see, are quite long, much more longer than what they normally are in the industry. They are almost 40 meters long, although the skin part, which is the gray part that you can see in the picture, is only 12.6 meters, which is equivalent to 7 rings. The shutters do 75 cubic meters pours, and we have 2 shutters, one on each tunnel, in full production, which means 2 pours a day on each shutter and 4 pours a day in total. These shutters are able to negotiate properly the curves of the tunnel, obviously, and also one key thing of them is the bogies that you can see the wheels on underneath the shutters. These bogies have given us quite a lot of flexibility when moving the shutters and setting them out in the tunnel, which has been quite a key thing in order to speed up and being able to achieve the production records that we wanted to get. An interesting part of them as well is the number of spat bars, which you're going to see in the next picture, or you can actually see down there. There is 6 spat bars on each side. And the reason for this is the important overloading condition that we had to fulfill in our project. We were not able to overload one single segment in the tunnel with more than 40 tons. This was prescribed by our engineer in AECOM, so we had to stick to this condition in order to make sure that we wouldn't move any segments in the tunnel, which would cause too many leaks and many repairs that we would need to sort out in the future. In this screen you can see now a few pictures of how we built the shutters. This happened pretty much on the worst time of the COVID in 2020. So despite of the difficulties, we were able to bring them on site, and as a team we built them, we put them on SPMTs, and finally put them underground, commissioned them, and at some point they were ready to work. As I say, the main challenge of these shutters, which was one main challenge as well in the Middle Tunnel, was the fact that overloading a segment could lead to a disaster. So we reinforce that not to happen by having a powerful PLC control that we developed with TecoSam. With this PLC, we managed to make sure that the loads were always stable and they were always spread across the primary lining, and we would not overload a single segment. Obviously, as well, the expertise of our team members by pouring the shutters in a certain way, vibrating, and many other things have made it possible not to create any mistakes. But the PLC was one of the main things that has made this prototype a great innovation. On this slide, you can see how we normally pour the shutters and how the PLC interacts. So basically, the spot bars that are located next to the skin are the ones that actuate at the beginning in conjunction with the bogies that are located on the sides. As you start filling the shutter tries to float, so the load starts to become higher, and the deformation of the curve of let's say the traveler starts to become more and more aggressive. And in the worst scenario, we have maximum 600 kilonewton that we can use on the spot bars, and this is the limit in which the shutter is trying to float, and there is risk of overloading the primary lining. In that situation, the PLC acts again and interacts with the spot bars that are located on both sides, so all of them actuate and they drop down the curve, as you can see. Also, the weight of the concrete helps the shutter to come down, so in the end the shutter is completely filled, and the last strokes of the pump, as you can see, they are done through a port on the crown, and with that we make sure that it's completely filled, but at the same time it's as stable as possible. Normally it takes us to pour 5 hours and 30 minutes. Sometimes we have been able to pour in 5, sometimes in 6, and when both tunnels were running, the pouring time was penalized, but at the same time we were able to pour both tunnels concurrently, so it was a benefit in the end. As you can see, this is the result of it. The result that has given to us is very good quality. I dare to say that Tideway for now are quite happy with what they see. The expectations are so far fulfilled. We don't see many blowholes, we don't see many things to worry about so far. The quality exceptional, I have to say, and the production has been very good as well. But of course, with the shutters are important, but the concrete as well. So here Hanson played also an important role, and we worked with Hanson closely for many months with trials on site in order to make sure we will get right the mix. We set up the on-site batching plant that you can see at the picture. This plant is able to produce 22 cubic meters an hour on a normal day, and considering that we pour 300 cubes a day between both tunnels, I have to say that this plant has worked quite well. We fill trucks, as you can see in the picture, with the concrete, and we take the trucks into the shaft, which is almost 100-200 meters away maximum, and then the trucks discharge the concrete into a drop pipe that then discharges into another mixer that Ricardo is going to explain later, and that's how the process works. The mix, as I say, was quite crucial. It's a steel fiber concrete, which makes it more difficult as well on the transport. And the key thing here was the sand. We started with a sand, the marine dredge sand, that turned out to be a bit dusty, and it would not suit our logistics. So we had to come back with Hanson and try to find another solution, and the solution was the Avenra sand, which is a land-based quarry sand. With this sand, we were able to keep the consistency of the concrete that we wanted, so we would have sand flows of almost 700 on top. And because of the logistics, because in the longest distance of the tunnel of 5 kilometers, it would take us 2 hours and a half to take the concrete to the face. In the end, the consistency gets reduced, and at some point we were getting 600, but that's exactly what we were requiring. So in the end, the concrete mix was also an important key player to get this done properly. I'm going to pass on to Ricardo.
Okay. Good evening, everybody. I'm going to talk a little about the rest of the panel and equipment we've been using within the tunnel in order to help delivering the concrete to the shutters. As well, I'll talk about the special push we managed to complete. So this is the moving gantry. This machine is based on the traditional Tbm gantries as an auxiliary backup to support the shutters and the concrete operations. It is composed of 7 gantries and a switch at the back to allow the train to travel in and out. And on the top level, you can find the auxiliary equipment necessary to comply to work within the tunnel, such as the rescue chamber, welfare facilities, the hydraulic power pack, or the HV rail that powers up the whole convoy. The moving gantry, one of the intentions of the moving gantry is the removal of the services and the equipment installed within the tunnel as it is coming backwards. So this will create a clear section of tunnel between the front of the moving gantry and the shutters for them to be set up and ready to get the following base pour. The moving gantry has been an essential part of the supply and the logistic for the production of the secondary lining. As you can see in those pictures, as the train is coming in the moving gantry with the concrete wagons, those will get parked at the discharge location, then plugged in not only for power reasons to keep the concrete moving inside the wagon, but to communicate them to the rest of the elements such as the conveyor belt and the concrete pump. And at this point, the final chain, the chain supply, it is closed. We've done a few more modifications that we implemented to the convoy, like a traffic light system to manage the movement of the locomotives, a more clear communication system for the operatives working in the shutters and the moving gantry. Also, all the information that is being collected from the temperature and pressure sensors installed on the shutters were transferred to a PLC, to a software that was designed by the PLC department and displayed into graphs and curves for the engineers, for them to understand and monitor better the process. Regarding the remixers, Tideway Central proposed a redesign based on the typical grout cars with the aim of achieving better access for cleaning and maintenance purposes. Obviously, this machine had to be a bit more robust and powerful to move that concrete inside of the wagon. As you can see at the bottom of the picture, that was a typical section of the pit bottom of the shaft at Kirtland Street when we were secondary lining both tunnels. As Nacho mentioned before, the concrete produced in the batching plant on the surface will discharge the concrete onto a big drop pipe 50 meters down the shaft onto a secatol or static remixer that keeps fresh the mix and is waiting for the remixer to travel underneath the tower and get fulfilled. Well, I need to say that although we did a few modifications at the early stage of the project on those remixers, the truth is that they have been a complete success for the secondary lining. Okay, as I mentioned at the beginning, we manage or we complete 6 particular pours where the connection tunnel meet to the main one. So it is in this part of the tunnel where the geometry of the tunnel had to change slightly to get a thicker section and allow the installation of the reinforcement. In order to achieve this new shape and create this new shape, we had to swap and change some of the panels of the shutter skin. All this work happened and it was planned to do in situ next to where the pours were going to take place. Well, you can see here how the works were happening when we were constructing those junction pours. The polyurethane piece that you can see on the figure was installed in order to achieve the oval section of the connection tunnel and leave the void for the future works. Just to give you some numbers, during this process it was involved around 85 cubic meters of concrete and an average of 27 tons of reinforcement. Well, some more figures for the operation. So, upon the completion of the junction pours, the projection of those connection tunnels on the main one were opened by saw cutting and eventually some stitch drilling Then waterproofing membrane and more reinforcement was what had to be installed, obviously, before the work happened, in order to tie back the connection tunnel to the main one. So far, 2 out of 6 connection tunnels have been accomplished by Falconbrook and Cremont remote site teams. So, to finalize, Ignacio.
We didn't want to miss the opportunity as well to talk about the program and the cost and all these important things as well, apart from the technical stuff. So in Central, as you can see, these are the program curves that we had planned, and as you can see in the picture on the westbound, which was finished back in September, we managed to get a 6-month improvement on the general program after a very, very small learning curve of 1 month, I would say. We managed to start doing a couple of pours a day. So there the team showed the great skills that they have in order to carry out the pours properly. And on the East Tunnel, as you can see, we had even a better start, which meant a 4-month improvement also in the general program of Tideway. Turns out that the East is also the critical path for Tideway Central. So this has resulted on a saving not only on program but in cost as well for the whole project itself. Since June of this year, we started doing consistently 4 pours a day, but not only that, we started getting the cycle down to 24 hours and even 22 hours, which was quite impressive. We were pouring consistently 300 cubes of concrete a day, which is almost more than 2,000 cubes a week, which was quite a great quantity, and Hanson were still able to supply us with the quantity of concrete that we needed. So far, we have done almost 10 kilometers of secondary lining, which has meant a huge saving in labor, only in labor, for the main tunnels. At the moment, the last pour that we carried out was the Addit in Kirling Street on the east. That was back in November. And since then, the convoy has been running from Kirling Street 7.6 kilometers up to Chambers Wharf. I think we're going to get there tonight, if all goes well. And we were planning to carry out a pour hopefully next week, otherwise sometime at the beginning of next year. And we only have 3 kilometers left, which hopefully takes us to the middle of next year. And with that, hopefully, we manage to get the secondary lining done and make Tideway Central a good reference for the future. I hope you enjoyed the presentation. Thank you very much.
Hello, evening everybody. As Kate said, I don't know how I managed to work on all 3 contracts and Lee Tunnel in my career, but anyway, I've been through all sites pretty much all over Tideway. So I'm going to talk about logistics of the Greenwich Connection Tunnel. As everybody knows, logistics can sometimes make or break these tunnel contracts, and proper planning at the start of the project just leads to better results during the project. Just a bit of an update on the progress so far. So Greenwich Connection Tunnel, we've completed in and around 1,770 now rings out of the 3,050, and around 57% complete. 2.6 kilometres done out of the 4.6 kilometres. We passed through 2 shafts, Deptford, just about 500 metres into the drive, and then Earl Pumping Station, which is about halfway into the drive. So 2 shafts were passed through. They were backfilled and flooded for our arrival. We passed through them and then out the other side. So all being well, we will be at sometime in the new year, we'll be at Chambers Wharf and ready to break through and remove the machine. So if anybody's not aware of the Greenwich Connection Tunnel site, it is quite a congested site. A lot of different assets and stakeholders all around the site. As you can see there, the site just behind the blue shading, we've got the acoustic shed. at one side of the National Rail and DLR lines, and then at the other side we've got the slurry treatment plant. To the bottom of the picture there, we've got the Deptford Creek. To the top of the picture is Norman Road, and then running through the centre you can see the National Rail and the DLR line. So sort of Greenwich is sort of squeezed into a sort of bit of a area just between the sort of four corners there. And you've got Greenwich Station as well, just off the side of the site, which is handy for getting home, but it's quite close to the site. Norman Road as well, as you can see there, which runs along the top of the picture, that is now closed to public as a public route, and that is used as our logistics holding area for all our deliveries to site and our muck away from site. So that's just used sort of solely for the Greenwich connection tunnel works. As you can see there, not ideal having a bridge run right through the middle of the site, but that's the way it is. The bridge passes just a few metres off the corner of the site. Did cause a few issues obviously during the site setup for craneage and for what we can store under and around the bridges. We've got our workshops under that. Just consent's required for what we store under there, and just proper risk assessments regard fire suppression and what exactly is contained there. But it's worked out well, but just takes up a lot of the site, and it is a bit of a hindrance. But we've got around those problems, and as you can see there on the plus side, it does provide excellent cover for the fitters whenever they're working on the workshops. So obviously the site is confined. Limited storage on site for all our consumables and our tunnel rings. So what we've got at Abbey Mills on the north side of the river, we've got our main logistics hub. That stores all our pipes, all our rails, all our grease and everything we require to keep the TBM running. So that's delivered directly from the supplier to Abbey Mills, and then each tunnel site, main tunnel D and the Greenwich connection tunnel, have their own dedicated wagons which ferry equipment to and from the site on a daily basis. So that works well, and it's a necessity just with the limited space we have on the sites. Abbey Mills, as you may be aware, is north of the river, Greenwich and Chambers Wharf south of the river. So one main problem is the River Thames that runs through between that and the Blackwall Tunnel. If anybody's driven in London, they know exactly what the Blackwall Tunnel is like and the problems it can cause. So that's just one risk regards traffic and just getting things to and from site. But as long as we've got an adequate stock at the start of the day, we can generally overcome a short delay due to traffic. Segment storage, which is going to sort of focus on, that is the main sort of issue around this site. You can see the acoustic shed there. It's sort of hemmed in between the DLR line. You've got the Greenwich pumping station to the south and the ongoing CSO works, which you can see there just by the Weldates crane. And then Deptford Creek and Norman Road to the west and the east as well. So the acoustic shed is possibly as big as it can be, and all space is used in and around that site. So as with most of the Tideway projects, work inside the shed is confined to the night shift, so we have to provide enough segments, enough consumables inside the shed to keep us going through the night shift and through part of the day shift. So we've got 12-14 hours production that we need to contain inside that shed. So that's why we need to make the best use of that shed and the footprint available to us in there. And then maximising the segment storage inside that shed is crucial to that. Segment supply, so our segments are delivered from Thamesport in Kent to site Monday to Friday or a Saturday if required. Good thing about this diameter of tunnel, we can get one ring on one wagon. Each ring weighs around 2,500 kilograms, sorry, 20,500 kilograms. So that can all fit on one wagon. The wagons do 2 to 3 trips a day, back and forward to Thamesport, supplying all the tunnel rings. Inside the shed, as you'll see in the next couple of slides, we can store about 26 rings comfortably, and we've got a bit of a buffer storage as well for 6 or 9 rings at the other side of the shed if we need them. And that keeps us going through the night shift and part of the day shift as well if the deliveries encounter any traffic problems first thing in the morning. We've got enough of a buffer to keep us going through part of the day shift. As you can see, what we utilised was the segment cassettes. So segment cassettes, as you can see there, made up of 2 main parts. You've got the cassette base and you've got the stacking frame, and one cassette holds 1 ring. These were designed by CVB and supplied by Tunnel Engineering Services. We purchased 60 cassettes and 40 stacking frames and about 10 of the adapters. So the adapters go onto the normal sort of container wagon and convert them into use with our segment cassettes. And that 60 number of cassettes provides us enough stock for the shed, stock for the storage segment site, and then stock for the wagons running in between the 2 sites and a bit of spare capacity. So they seem to be working quite well. Segment handling. For segment handling inside the shed, we have a twist lock lifting attachment. So as you can see there, the lifting attachment on the top of the top photograph, it's based on a container lifting device, similar to shipping containers, where it drops down. There's 4 twist locks either corner, and then that twists into position and enables to lift the segment cassettes. There's locating guides on the lifting attachment itself and on the stacking frame, so that allows us to drop them into position fairly easily without too much manipulation. That removes the need for any personnel in close proximity to the lift. Just a bit of a tweaking with the tag line, we can get it lined up, drop it down and into position. As I said, that reduces the need for any personnel in and around the lifting. The gantry crane as well, we utilise the cab as at a high level, so that gives a direct view of the load and of the lift in and out of the shaft and for the stacking, so it's a clear view of the load from the gantry crane operating position. As you can see there, shed full or near enough full of segments. We stack the segments free high, so that's one of the main benefits of the segment cassettes, is we can stack them free high and make the best use of the small footprint we have at one side of the shed. Another positive point about the segment cassettes is the segments come to site contained inside the cassette, so there's no direct lifting of the segments, which minimises the risk of any damage to the cassettes. And it means that we travel into the Tbm with the cassettes without any risk of damaging them. We've got 2 gantry cranes in the shed, one at the east and west side. One gantry crane is dedicated solely to the segments. During the day shift, it offloads the segments from the wagon and then it stacks them and also supplies the tunnel with segments as well. So on a typical day, we offload and around 28 deliveries during the 10 or so hours on the day shift, and also supply the tunnel with 18 rings. So as you can imagine, that gantry crane is quite busy all through the day shift, supplying the tunnel and stacking and removing segments from wagons. Tunnel transport, quite conventional, as of most TBMs. What we do, lift the cassette from the top, lower it down to pit bottom, lower it onto the flatbed. The flatbed's got a twist lock attachment as well, which locks the cassette into position on the flatbed. The top frame, blue frame you can see there, is then disconnected, the 4 pins in the corner, disconnect it, and then taken to the top. Segments go to the TBM, removed on the quick unloaders on the TBM, same as most systems, and then out again with the empty cassette. And then once it's out, the top frame is then lowered down to pit bottom, connected up again to the cassette base and removed to surface. And on day shift, sometimes it's removed to surface straight onto an empty flatbed that is waiting and out. our empty wagon that's waiting out to the off-site. Again, quick unloaders, they're designed so that they don't interfere with the Tbm or any of the tunnel plant throughout the tunnel, because you can see they're slightly wider than the tunnel ring itself. So we've just had to make sure that all the plant and all the slurry pumps throughout the tunnel are just designed to allow enough clearance for the cassettes to pass. And the flatbeds as well are multi-purpose, so once the cassettes are removed, it just acts as a normal flatbed. As you can see, after a very productive night shift, you've got a shed full of empty cassettes, so that's a bit of an exaggeration. We generally don't have a few rings left, but we've got none at that moment. But it just shows you the best use of that space in the shed for the cassettes and the stacking system and the neat rows, and the yeah, it's a good system which works well. Just quickly going to mention about again, I've mentioned segments, I've mentioned the consumables, pipes, etc. Now the slurry. As I mentioned at the start of the slideshow, we've got our site which is split into two sort of distinct parts, the slurry treatment plant and the drive site and shaft site on the right hand side of the picture, and the national rail line through the middle. One of the downsides of that is the transport of the slurry from the shaft to the slurry treatment plant, and what we've done is we've got a culvert across the site below the pedestrian footpath in the bottom left there, below the arches of a national rail line, and then across the slurry treatment plant site to the desanding and desilting building at the far side of the site. So yep, that's the way it had to be done, just with the confines of the site, and yeah, it works well, as I've said. Pedestrians, I'm not sure if they realise that while they're walking along there's 1,000 odd cube an hour running below their feet, but anyway. And then muck away itself. So from a Tbm, on a good day, we process and produce about 3,000 tonne of muck, of chalk, per 24 hours. We muck away by road and by river, just with the constraints of the Deptford Creek. We can't get all muck away by river, so we've got a back of the trucks as well, of the wagons, which can come onto site. But we do make best use of the river when we can. So far, we've removed around 75,000 tonnes by river. That equates to about 45% of the total muck generated by the project so far. And the rest of it has gone off site by wagon. Tideway at the start, our target was 30% for muck away by river, and we're now at 45%, so well exceeding that, and that's going to continue towards to the end of the project, and that equates to around 4,500 wagons taken off the road so far. So a great achievement there to make the best use of the river. The site at the slurry treatment plant site is not as restricted as our drive site. We've got a reasonable amount of room there to bring our wagons on site, load them and get them turned and get them off site. So yeah, it works well there as well. During the night shift, again, we're restricted as regards muck away, so we can have no plant movements in and around the site, and loading of barges. So we've maximised the amount of room or space available on site for muck storage. So we've got additional muck bins between the river and the filter press buildings, where we can store muck during the day, and then ready for the barge in the morning or during the day shift. And the filter press walls as well, as you can see, 9 metre high walls, which provide again storage for the night shift mining operations. And yeah, that's all from me. Thank you very much.
Okay, it falls to me to wrap up and look ahead to 2022 and see what we got left to do. And Bob, I will tell you when we're going to finish. So again, right briefly, this is an image created probably at the DCO times, 2015, of what Putney would look like. And as part of the planning application with the river walls and the fendering, etc. And currently, you can see there where we are at Putney, and across a number of our sites. So it's nice to see the shapes appearing now, the new realigned Thames, what we're going to end up in that legacy. You can see the fendering going in and the river walls being clad. Secret here now is to ensure we get the permanent flood defences in place, get all the finishes complete, so we can remove the cofferdams. A lot of work. We spent a lot of time getting into the river, and now we've got to start coming back out of the river so that we can do the final outfalls and any scale protection measures that are required around some of our structures. Just another one, this is at Albert, big building in the middle, is MI6. You can see there's a shaft-like structure there beside the bridge. It's actually a rectangular structure under that circle. That's just an architectural finish. But then the other promontory into the river at the bottom left of the slide shows where the main shaft is on this side, and you can see there the two ventilation columns. And again on that side, you can see, and again this has been replicated across most of the sites on Tideway. The river walls are being created, the finishes are going on. We're up to cover slab levels now. So the secret is now to finish off those finishes, get cover slabs on, and a real secret for us is to get everything below ground done, sealed, out of tunnels and shafts to now enable the subsequent progress. Across the programme, the mica works have started. What you can see here on two of the sides are penstocks and flat valves which control the flows into the sewer. So we can isolate the sewers from the Tideway tunnels whenever we need to, either for operational reasons or if we have to do maintenance in the tunnels. These are vital to allow our commissioning strategy because we need those in place before we can commission the whole system. And then programme. You can see the line where we are today. Key things that we've got to complete. The CVB team have got to complete the tunnels in East. Like both tunnels in East are over halfway through. They should complete April, May next year. Following that, they need to do the secondary lining. In West and Central, secondary linings in the tunnels are ongoing. Those need to complete. And then we'll see a real sort of scale up of all the mica works, etc. And the key date for us is trying to drive forward to the start of commissioning. Once we start commissioning, that means we're out of tunnels and shafts and we can accept flows into the system. And that's a key date for us. And we need to get out of the tunnels and shafts. You'll see some of the construction activities go on beyond that, and that is due to start commissioning, we just need the system in place. We don't need all the architecture and landscaping done, and we don't need to be out of the river on all sides. So some of those works will carry on while we're doing the commissioning of the system. And then through to the final acceptance. It goes on until 2026. People ask, why is it such a long commissioning and acceptance period? Basically, we've got to wait for the rain. We've got to have a numbers of storm events to flood our tunnels to be able to fully commission it. And there is an allowance in these bars for, hopefully, we get those storms day one. And then that will bring that commissioning phase forward, but we have to wait for the rain, in essence. But then, if you go along the Thames now, on a number of the sites, you will see the architectural and landscaping features emerging from behind the cofferdams, and it's really nice to see that happening. And I think we're virtually at the end, and because Andy Alder didn't make it today, he's given me this slide, and I was going to make Andy is committed to that when we do start taking those flows, the brown river that you see there will become crystal clear and dolphins again will be doing backflips in the Thames. Perhaps I exaggerate a little, but once we do start taking the flows, we do start improving the quality of the river and we start delivering on our legacy that we promised for London. So I think that ends it, a few thank yous to all of those on the screen now for delivering Tideway currently, for the team over here that have delivered some fantastic presentations, and to all you for listening. Thank you.
Okay, we will now open for questions. We've got a few roving mics, and I think we've got a little bit of a revised wet wipe process for tonight, just to sort of just take the mic, we'll deal with the cleaning, I think is what I've been advised. So yeah, if you could give your name and affiliation and ask away.
Mike McConnell, retired from Balfour Beatty. I think first of all it's just a fantastic congratulations to everybody tonight. Each in your own way have really given added value, those little snapshots tonight of the whole scheme. I think the lasting impression I have is of the quality that you're achieving and in that context of the logistics management, that obviously seems to be going very well. So I just want to briefly, Chair, if I can ask two simplistic questions, if you like. The thing that I see is an awful lot of different sections of tunnel works, as it were. There are 3 main contracts, as it were, but an awful lot of individual operations, quite a lot of them quite similar, if you like. So I was just wondering how the client actually arranged feedback to be occurring between the different sections, if there was some best practice happening, or good productivity from certain gang sizes happening there, or just anything really that can be replicated in some of the other areas, like the eastern end, that hasn't started. So just a snapshot as to how the client ensures that we don't reinvent the wheel or make silly errors. And then secondly, on the main subject of the actual procurement of the TBMs, was that a client's procurement to actually procure the TBMs? And was the client actually taking a certain element of specification risk with the actual TBM machines themselves? And in hindsight, was that a good decision if the client made those decisions?
Okay, I'll take that. Your first point is on effectively transferring the lessons from one area to another. And I must admit, I've not been on a project that has done this as well. All of the contractors have been fully open and sharing the good and the bad. And John Corcoran in the audience today chairs our health and safety group for tunnelling, and monthly we meet and we're sort of swapping ideas continuously. Just because we're looking at like secondary lining now, just showing you what's happening at the moment. In the central section, they're getting near completion of their secondary lining. The east team have picked up virtually the identical mix and copied that mix design because it works. And that has gone into it. They're also procuring the logistics gantry from central, and another benefit for us is that's on the site at Kirtling Street. CVB are there doing slight modifications to it to suit their proposals, and then that will just go on to a barge and sail up the river. So it doesn't all have to be completely disassembled. So it saves us time, and that's happening across all 3 areas hugely. And it just so happens today I was on a call with HS2. So we're now embedded with the HS2 organisation, making sure that any lessons from Tideway get moved on into that programme of works as well. So there's a lot of learning going on. And like I say, I don't think I've been on a project where it has been so open. I think when you put tunnellers in the room, they like to talk. Yeah. And TBM procurement, the TBM procurement was done by the contractors. Tideway produced minimum TBM requirements, similar to like a Crossrail spec or a development of those with Gordon Ince and the team. So we issued minimum specs to the contractors, but they did the procurement of the TBMs.
Okay. I think we've got another one at the back.
Yeah, good evening. Thanks very much. Shani Wallace from Tunnel Talk. I have a question about the internal lining, the secondary lining. You mentioned just now that it's the same mix on 2 of the main contracts, and I'd like to know a bit more about the design of the internal lining and the reinforcement on each of the sections and the thickness, and also the maximum internal pressures that the secondary lining is designed to withstand. Thank you.
I can respond some of the questions, I think. Our secondary lining is 250 mil thickness. Sorry? Yeah, in the junctions, obviously the thickness varies up to 450, I think it is on the junction side, as the tunnel protrudes into the main tunnel. We have steel fiber concrete, and we only have reinforcement ourselves in the junction area. And it takes about from 20 to 26, 27, depending on the junction, tons of reinforcement on each of them. We don't have any reinforcement in the adits either, and we do have reinforcement a little bit only on the very top of our shaft, next to the capping beam, but that's pretty much it. In terms of the loadings, getting too much into the design, I'm not sure if I'm able to respond.
I think it was a maximum of 600 kilonewtons. The spat bars can...
Yeah, but is your question around when it's fully commissioned, yeah?
Yeah, the maximum internal pressure that the internal lining is designed for.
I don't think we have the answer up here, but
Yeah.
one thing about the pressures on the internal lining, I don't know the numbers, but the design has to cater for an internal pressure, but also a negative pressure, because there are hydraulic issues with it that we can be effectively trying to suck the secondary lining away from the primary lining. So it has to cater for both of those. And I assume as we go deeper down, we've got the pressure in the eastern tunnels, because they're at a depth of circa 60 metres, compared to in west, starting at 25 metres, something like that. There's that hydraulic head as well to deal with. But just on the reinforcement, on all three areas, they're all fibre reinforced. Like Ignacio was saying, at junctions where there's different forces, there are sections that have to be reinforced. And in the western section, because we have had some issues on the early pours, when we're pouring them, they're poured in bays, your hit and miss panels, and when you're doing the infill panel, the load from the formwork gets transferred into the freshly cast secondary lining, and that has been causing some cracking. So we have got some sections where we had to put in some reinforcement to minimise the cracking induced by the load, the temporary works loads. Subsequently, they've been able to modify the formwork to minimise that loading, and we've been able to, I believe, eradicate that rebar again.
And the thickness of the internal lining? The thickness of the internal lining, it's the same up at the west as it is down in the east, is that right?
Well, the west tunnel is a smaller tunnel on diameter. I don't know what the west thickness is, per se, but the central and east tunnels have got the same thickness, because they're in the 7.2 lined tunnel. We at planning stage, we had allowed for a slightly thicker lining, and value engineering, etc. We've been able to slim down the lining, minimising concrete, minimising carbon, and all those issues.
Very good. And the internal lining is not needed in the laterals, the feeder tunnels?
No, I think virtually all tunnels have a secondary lining. On some of the smaller tunnels, we've done I believe a combined primary and secondary lining on some little pipe jacks with an enhanced pipe in effect. But generally, all the tunnels are secondary lined. There might be one or two small exceptions to that.
Thank you. Thanks.
And our shafts are all secondary lined as well.
We have another one.
Thank you, David. Excellent presentation, everyone. I'm Jamie Bradley from Balfour Beatty. So my question is, during and after secondary lining, did you experience any water ingress that was above the contract requirements? And if so, what were the remedial measures?
Not so far. We did experience, I think, a couple of leaks, one on the east at the beginning and one on the west, but it went away quickly. We didn't have to do anything, I believe. We still need to, because of the situation of Tideway, as you know, we were working back from Carnwath Road to Kirling, so the tunnel was getting in darkness because we didn't have an open end. So now, now that the shutters are coming out on the west drive, we need to go back and inspect the whole tunnel again and see what it looks like. And we need to do the same now on the east. It's something we still need to assess, but so far we haven't had any issues.
And for what it's worth, we didn't at Frogmore either.
Yeah. And in the east section, obviously there's no secondary lining done as yet. We have got a few leaks through our primary lining, as we would expect, because they're very deep, under high pressure. And we're currently trialling now some injections into those to try and get that all underway and done prior to us coming in and doing the secondary lining, so that we don't have any issues with delaying the secondary lining.
Thank you.
Okay, we have time for one more. Okay, I have one myself actually for each of the representatives from each of the projects. What would each of you say is your biggest lesson learnt or thing that you're going to steal with pride and take to your next tunnelling project?
I guess this is my first job. I don't really have any comparison with other tunnelling projects, but from people that I've spoken to, I think there have been quite big emphases on safety, so really thinking before we even start anything happening on site, really reviewing the work practices, talking with the men. I think I found is also something that has been really valuable when planning works, and just gets them more engaged and then more also willing to take responsibility for the way that they're doing the work if they've been involved in organising it, which we're encouraged to do at Tideway.
Well, personally, it's my second tunnel, and despite that, I've been through the whole tunneling process from the TBN until now, the secondary lining. I think for me, I will pick up as a very good experience a part of the secondary lining and concreting work, since I never did it before. The hyperbaric interventions to me were like a good achievement, and how they managed the team to develop and carry out this work was exceptional. Was very great.
I'm gonna focus, I guess, on secondary lining. For me, and I think I read something like this from John Corcoran, and I think the key for the secondary lining is to plan ahead a lot. Some people seem to underestimate the operation because it's not TBMs, but it actually takes a long time to plan everything ahead, and if you want it to get it properly done, it's got a thing that the TBMs do not have, and it is that it really depends a lot on where everything is placed on site, where the batching plant is, how you take down the concrete, how your shaft is, and that changes in every project, and planning ahead to me is the key thing. And do not underestimate the secondary lining, because the plant sometimes gets quite complex, and if you want to get it right, you need to have a good planning. So that's from me.
Well, yeah, mine is maybe more general. It's just sometimes thinking outside the box. Just because you've done something previously a certain way doesn't mean the next time you have to do it the same way. Just sometimes, pardon the pun, tunnel vision, but it's thinking outside the box and come up with your own ideas and innovations just to try and solve a problem or try and do something differently or better than it's been done previously. And then as well, just trying to take as much information and experience from on-site people and people who have been in the industry for a long period of time, just try and suck that information out of them just to aid your own experience in your own career. Good.
Thank you. So I just want to say once again, thank you for bringing this evening to us an excellent update from the project. It's been really fantastic to have the project back tonight. And if I was reading correctly, I think we may be able to squeeze another one in next year. And maybe some of the special requests of the questions that are maybe still out there for the project. Put your special requests in and we'll see what the guys can do for next year. But I'm sure if you have questions for them, they'll be willing to get back to you on things from the project. So really just want to say a big thank you to each of you. So that's to Maurice, Jennifer, Ignacio, Ricardo and Matthew for coming here tonight and giving this update. So if we could have another round of applause, that would be great. So I do have a couple of announcements tonight, so if we could move to the next set of slides. So yeah, once again, we are still celebrating 50 years of the BTS, and it is great to be able to discuss that with you here in person. So next slide. So as a reminder, unfortunately, the bar downstairs is still shut. However, we are, if you want to come for a drink, there'll be many of us heading to the Westminster Arms this evening. We don't have, unfortunately, an area booked, but I would imagine many of us will be out on the street if it's packed inside. So we look forward to joining many of you there. So then the next one is to hopefully join us on Thursday the 20th of January for our first event of the year, and this is Small Steps in Sustainable SCL. And at the moment we are hoping that will be in person, but watch this space, so please look out for the announcements as to where it will be. We then have our next event on Thursday 10th of February, and this is a joint event with Min South, and this is on the Kidston Pumped Storage Project from Queensland, Australia. So just as a reminder, we are always welcoming any papers or lecture topics that you have. Even if it's not for yourself to give it, you might be able to link us up with someone that wants to come and tell us about something interesting. So please get in touch. In particular, if you talk us either the BTS email address or contact Sarah Langley. Papers on any subject relating to tunnelling, and if you could put your submissions in by the 11th of February, and it's open to any individual aged 33 or under. We also have the call for the Doug Allenby Memorial Medal. This is a new award, and it will be awarded at the BTS YM Conference 2022, and the call for applications is by the 6th of February 2022. And as a reminder, gave a little bit of a sneak peek in the previous slide, the BTS YM conference returns this year on the 18th of March 2022. So similarly, look out here for more details on this, and it'd be great to have as many interesting papers as we've had in the past. So the next one then, it's a bit of an update from Tunnel Skills. They are really looking for your feedback on the virtual reality training that they've put together. So if you haven't checked out the immersive learning that they've got so far on their website, please do. They'll be more than willing to come and tell you more about it as well. Fantastic tool that they've created there. And then just as a little reminder, we did this year create a series of songs linked to the BTS book that we've been developing. So if you haven't heard them yet, I never thought I'd be in a position to say that the BTS has developed some folk songs, but we have. So please take a listen, as it's packed with extracts of all the different stories that people have told, and that has inspired Nancy Kerr, she's an excellent folk singer, to be able to put our industry into song. So please take a listen. So a little bit then on the book. As many of you have been coming to these events for some time, progress is still continuing. We have now got 501 stories and lots of introduction bits. It's getting quite big, 856 pages. It could still go up, but progress is continuing, and many of you might have seen just how big this is getting. But you've all got a lot to say. So progress is continuing, but we are still looking for support to get this over the line. So we've had a lot of contribution, and we are closing the gaps, and we will contact some potential authors. But what you will see is there are some other stories about some people that we know have made a big impact on this industry that we are looking for. So If anyone would like to provide one or more pieces, please get in contact with Ken Spivey. It may even be something really, really small, but we would really value any support and help. So yeah, please check in with Ken. So programme-wise, we are hoping to go to print in April 2022, with copies being ready by end of April, May. And just a big thanks to our sponsors so far and those that have pre-ordered. And pre-ordering, I've been told, should be available shortly. So yeah, we really just want to give a big thanks to all of the volunteers and the sponsors so far, but I've been advised there is still time to sponsor, so if your logo is not yet looking like it will be on the back page, please get in contact. I think it would be a while before we did one of these ventures again. So yeah, as it says, it is a virtuous circle. The more sponsorship we receive, the cheaper the book will be. So find out more to get involved. So yeah, I think I've got one, have I got one more slide? Yes, so just a big thanks. So that leaves me then just for one thing to say a big Merry Christmas. And here we have got our own resident BTS Santa. This is Mr. John Sholey wishing us all a Merry Christmas in true Santa form. He can't be here tonight, but hopefully he's watching online, and he just wanted to say a big Merry Christmas. So from me, take care and good night.